This is AP Calculus Self Check 9.3 solutions. Let's jump right in. Average acceleration. All right, so we're given velocity, so we need to get acceleration. So acceleration is going to be the derivative of velocity. Therefore, to find the average, we're going to do 1 over 80, the integral between 0 and 80 of acceleration. And acceleration is v prime of t dt. All right, so what does that turn into? We know that to find the slope, this is the slope of velocity, we need to calculate the average slope essentially. So this is going to be velocity of 80 minus velocity of 0. All of this is going to be divided by 80 minus 0. So this turns into velocity of 80 is 49, so 49 minus 5. All of this divided by 80. That turns into 44 over 80, which reduces, divide the top and bottom by 4, to 11 over 20. And what are our units? Average acceleration. So our units are acceleration. It's feet per second squared. Feet per second squared. All right. Using correct units, explain the meaning of this thing. So integral between 10 and 70 of vt, the velocity function dt. What does that mean? It means, so if we're going backwards from velocity, we go position. So this is the total change in position, or the total distance. It means total distance, our units here, so when we take the integral of velocity, we go back to feet, so in feet. And that's from 10 to 70 seconds. All right, and use midpoint Riemann sum with 3 subintervals of equal length to approximate this thing. Okay, so our 3 intervals are here, here. Oh, I apologize. It's from 10 to 70. So 10 to 30, 30 to 50, and 50 to 70. There are our intervals. You have to start at 10 and at 70. All right, and here are the heights for those midpoints. That is the point in the middle. So to do this, notice that each of these has a distance of 20, distance of 20, distance of 20. So the quicker way of doing this is to say that the integral between 10 and 70 of velocity, I don't know what happened there with my pen, velocity with respect to time dt is approximated by the midpoint Riemann sum, which is 20 times all of these values being added up, and you distribute the 20 into those. That's the quick way of doing it. 22 plus 35 plus 44, and that's going to be equal to 2020, and our units here are in feet. Before I move too far, I want to talk about how to score this page. So part A is out of 1 point. If you got the answer of 11 out of 20 and you have feet per second squared, you're good. So that's +1 for the answer. Part B, that is going to be out of 3 points. And so you need the explanation, this total distance, that's +1. And if you have these values, 22, 35, and 40, give yourself +1. And if you finally got the answer, 20, give yourself +1. All right, so for part C, we need to find the 2 different velocities. We need to find the velocity of rocket A, so the velocity of rocket A, we'll do capital A, at time equals 80 seconds, so velocity A at 80. And we need to find the velocity of B at 80, velocity of B at 80. So the velocity of A, that just comes from looking at what the velocity is at time equals 80. You see that it's 49. So we're going to say that is 49. We're basically done with that one. B is the hard part. So how do we find B? It gives us acceleration and it expects us to find velocity. You should be thinking of integral. So this is going to be, I'll say we're working on B here. So time, we need a start plus change, and that will equal our end. All right, so our time is 80. Here's our table here. Our start value is 2, so we're starting with a velocity of 2, and our change is going to be the integral of our acceleration function between 0 and 80. 0 and 80 of acceleration with respect to t dt. So how do we find this thing by hand? Remember, this is problem 3 from the 2006 AP free response questions, which means you cannot use a calculator. So to find the integral between 0 and 80 of this thing, this is 3 divided by the square root of t, okay, come on now, t plus 1. I need to do this by hand, so let's go ahead and do that. So when I reconfigure this, so I get rid of the fraction, get rid of this radical, this is going to be the integral between 0 and 80 of 3 times t plus 1, all of that to the negative 1/2. The negative comes from getting rid of this denominator and moving it to the numerator. The 1/2 comes from getting rid of the radical. All right, do we need to use taxman? The u here is t plus 1, du is just 1. If du is 1, we do not need to use taxman. So let's go ahead and just take the antiderivative. So this 1/2, we're going to add a power, so it's going to be t plus 1, negative 1/2 plus 1 is just a positive 1/2, and then I divide down. So 3 divided by 1/2 is the same thing as 3 times 2, which is just 6. That is evaluated between 0 and 80. So to evaluate this, we should note that this is really 6 times radical t plus 1. And when we plug in 80, we're going to get, and I'm going to pull out the 6. Ooh, I don't know what happened there. I'm going to pull out the 6, and I'm going to evaluate now. So 80 plus 1 is 81, and square root of 81 is 9. Or I can just write this as, we'll leave it as square root of 81 to see our work better. And I'm going to subtract when I plug in 0. 0 plus 1 is 1, so it's going to be the square root of 1. All right, so this is going to be 9 here. This is going to be 1. 9 minus 1 is 8. So this is going to turn into 6 times 8, 6 times 8. And our final answer is 6 times 8 is 48. Well, it's not really our final answer. Final answer from this integral is 48. So this is saying 2 plus 48. This whole thing is 48. So our 50 is our end value. So which one is higher, 50 or 49? Obviously it's 50. So VB is higher than VA, and our answer is B is going faster. Which of the two rockets is traveling faster? B. So we're going to say rocket B is traveling faster. And our rationale, our reason, is because the velocity of B at time equals 80 is greater than the velocity at A at time 80. And if you really want to make it known what those values are, we could have said that one was 50, this one was 49. How to score yourself. So let's switch to red here. This is going to be out of 4 points to add up to 9. So 1 point if you somehow got this part. So plus 1 if you got to 6 times radical t plus 1 or t plus 1 to the 1/2. If you got the constant of integration, so if you got this to the initial condition, if you included that, it's really not the constant of integration, I guess, but if you got the 2, give yourself plus 1. If you found v of b and compared it to v of a, so if you found v of a, I'm just going to say plus 1. And if you drew your conclusion that rocket B is traveling faster, give yourself plus 1. So that is 1, 2, 3, 4 points. And now on to self-check 9.4. So we have this test plane, we're using a midpoint Riemann sum, which means we're taking from 0 to 40, so let's make that a little bit better, going like this, from 10 to 20, from 20 to 30, and 30 to 40. So that is 4 intervals, and it says we're using 4 intervals. That makes sense. And midpoint means we're using this point, we're using this point, we're using this point, we're using the point in between the values that we're choosing. Notice that each of these distances is 10, very similar to the last problem where all the distances were the same, which means we have a shortcut here. So first let's calculate the approximate Riemann sum. This is going to be from 0 to 40 of Vt. We're going to say that this dt is approximately equal to, and our shortcut is we'll pull out the 10, and we're just going to add 9.2 plus 7.0 plus 2.4 plus 4.3. And that is going to be, so it's 10 times, add all those up, that's 22.9. And that, come on now, that turns into, just move the decimal place, 229. And what are our units? When we take the integral of velocity, we go back to distance, so it's just in miles. Miles. But we're not done with part A because it asks for, using correct units, explain the meanings. What does this thing mean? What does 0 to 40, the integral from 0 to 40 of velocity of t dt mean? This thing means the total distance traveled. Total distance traveled. And what are our units? So in miles. And then from where to where? From, so from 0 to 40, from 0 to 40, and our units here are in minutes. How to score part A. So part A is out of 3 points. You get 1 point if you got all of these values correct. You didn't have to keep them like this. You could have done 10 times 9.2, 10 times 7.0, 10 times 2.4, etc. And you get 1 point if you got the answer of 229, and you get 1 point if you said total distance somewhere in your sentence. Okay, part B. Based on the values in the table, smallest number of instances where the acceleration plane could be equal to 0. This one was a little bit challenging, but note that there are repeat values in this velocity. So I'm going to highlight those with red. So look at this 7.0, this 7.0, and then we'll switch to black for the next highlighting, this 2.4 and this 2.4. They are the same value. So if you recall all the way back to unit 1, that was our first unit, what was the theorem that talked about slopes? It was EVT, IVT, MVT, one of those. If you said MVT, you are correct. So we're going to say by MVT. And before I move on with MVT, just to note what MVT says. MVT says that f prime of c at some point in the interval between a and b. Remember that between a and b, c is somewhere in between there. So some random point between this interval a and b. The derivative of f prime of c must be equal to the average slope. So the instantaneous rate must be equal to the average rate of f of b minus f of a, I don't know why my pen keeps doing that, f of a all divided by b minus a. And that happens at least once. It could happen more. The rationale for that is if I have a graph of 2 points with the exact same value, like it could happen once. See, there's f prime equals 0. It could happen twice. I could go, there's 0 twice. And it could just be a constant line like this, and it just happens infinitely many times, I guess. So just keep those in mind. So by MVT, it guarantees that if I have the same two values here, then there is the derivative of v prime is equal to 0 between those 2 points at least once. So how do we say that in a sentence? We say by MVT, our v prime of t, the derivative must be equal to 0 in those intervals. So between 0 and 15, in 0 to 15, and the other interval, which was from 25 to 30. All right, and so by MVT, that happens. So acceleration, our final conclusion, acceleration will be 0, 0, 4, and remember, it's at least 2 values of t. Again, it could be more because we had the graph up here that went like this, where you had 2 values like that. All right, so how to score yourself. This is out of 2 points for part B. And where do the points come from? So you need the 2 instances. So if you have these 2 intervals, give yourself +1. And if you have your explanation, so you have to have mean value theorem, and you have to say there are 2 values, give yourself another +1. Okay, on to part C and D. These problems are particularly hard. I know that this is going to be Form B for the 2004 AB free response questions. Form B does mean it's harder. You would think that you'd have a calculator for C and D, but you do not. You have to do it all by hand. So how are we going to do this? Well, first of all, we know that we're given velocity now. So this is a brand new function, and it is velocity. We're trying to find acceleration. So you should know, if I'm trying to find acceleration, that should be taking the derivative of velocity. And you might want to even write this down too. You don't get points for it, but the derivative d dt of velocity, vt, that will give us acceleration. And acceleration, so that's going to be the derivative of this, so it's going to be f prime of t. And what is f prime of t? We actually need to find that. So derivative of a constant is 0, so that goes away. Derivative of cosine. So remember, this is going to be chain rule. Chain rule is going to pop out a 1/10 for the inner. So Daughter times dinner. Dinner is 1/10. I'll do that first. And then Daughter, cosine. So cosine is going to change to sine, and this is going to be change. C stands for change, so it's going to be actually a negative 1/10 sine. Come on now, sine of t divided by 10. T divided by 10. And that's going to be added to, and this is going to be, again, I'm already going to do Daughter times dinner. Dinner is going to be 7 over 40. 7 over 40 times that 3 is going to be a 21 over 40. I did Daughter before dinner, or I did dinner before Daughter. Now I'm doing the Daughter, the derivative of the outer. So sine. If I take the derivative of sine, it turns into cosine, and s says same, so it's the same sign. This is now going to be cosine of 7t divided by 40. All right, so that was the derivative, but we need to find the derivative at time equals 23, and we need to indicate units of measure. Don't forget those last two. So now we're going to say, well, the acceleration at 23 is really going to be f prime of 23. And we found f prime. So all we need to do now is plug in 23, don't evaluate, and we get the points for this. So this is going to be negative 1/10 sine of 23 over 10, 23 over 10. And you can do 2.3 here, but it's better to just do this so you don't make any mistakes, plus 21 over 40 cosine of 7. I'm just going to leave it as 7 times 23, all of this over 40. And I get my points for this. And if you do evaluate this on your calculator, you're not allowed to use a calculator, you will get about negative 0.408. But we're not done because we have to indicate units of measure. So again, this highlighted black part, we don't need him. You can kind of erase him from your mind. This is just to make sure that you're getting the right value to check your work at home. But we need to have units of measure to get full points for this. So the units of measure here, we're taking acceleration. So acceleration should be, what were our units over here? Acceleration is miles per minute per minute. So miles per minute squared. All right, how to score this one? This part C is just going to be out of 1 point. If you got this answer here of this giant block here, and you got the units, so you had to have both those parts, then you give yourself +1. I know, a lot of points for just 1 point, or a lot of work for just 1 point. All right, on to part D. According to this model, what is the average velocity? So average velocity, if we gave the velocity, we need to find the average of that velocity. So this is just our definition. Average velocity is going to be 1 over 40, integral between 0 and 40 of velocity, vt dt. So it's not enough to just write this. I think we need to actually find an answer. Yeah, we have to find what this evaluates to. That's why this is Form B, and this is going to be a lot of work. Here we go. So what is this going to be? This is going to be, in fact, I'm not even going to write it like this. I'm going to write it to save a step. This is going to be the integral between, whatever. I'll just keep it like this, dt, because eventually I'm going to need to break this up. So this is going to be equal to 1 over 40, and that's going to be all on the outside. What's going to be on the inside? So I'm going to break individual parts. These are going to be integral of 6, integral of cosine, integral of sine. These are going to be 3 different integrals because I know I'm going to have to break them up anyway. So this is going to be integral between 0 and 40 of 6 dt plus integral between 0 and 40 of cosine of t divided by 10. This is going to be plus integral between 0 and 40 of 3 sine of 7t over 10. Or sorry, not 10, 40. I forgot my dt here, didn't I? dt, this one is going to be dt as well. And we have to evaluate this thing. Okay, here we go. And again, you don't have to actually find cosine of a number. You just need to take the antiderivative and plug in your numbers, and you can call yourself good. So here we go. This is going to be 1 over 40 still. And do our brackets. All right, so integral between 0 and 40 of 6. Again, this is 40 minus 0, which is 40. 40 times 6 is 240. 240. That integral has been evaluated. This one now. Okay, notice that our du, our u is the t divided by 10. So du in this case is going to be 1/10. It's not 1, which means I have to use taxman. I have to use taxman twice. This one is also going to need taxman because du is not equal to 1. So I'm going to do taxman really quickly in my head, and hopefully you can follow along. So this is going to be plus integral between 0 and 4. Come on, 0 and 40. And cosine, so this is going to be 10 times cosine of t divided by 10. I use taxman. I'm about to take the antiderivative in a sec. That's dt, and that's going to be plus the integral between 0 and 40. I'm using taxman again really quickly, and that's going to be 40 divided by 7 times 3. So 40 times 3 is going to be 120. 120 over 7, and then sine of 7t over 40 dt. All right, that was a lot. We're still not even there, though. So now what does this evaluate to? This now turns into 1 over 40. I think I'm going to need another line down here, so I'm going to scrunch this in. And that's going to be times, we still have that 240. Now we're going to evaluate this thing, take the antiderivative. So anti-C, C stands for change. Anti-change means the same. It's going to be the same sign. This is going to be then plus 10 and then sine of, I'm going to go like this. T divided by 10. I was thinking about trying to evaluate at the same time. All of that is going to be evaluated between 0 and 40. So I'm going to do another set of parentheses in here to let you know that evaluate this thing and then add it to 240. This is going to be plus. Now, this is antiderivative of sine. Anti, same, means change. This sign is going to change, so it's really going to be minus. And again, I have 120 over 7. This is going to turn into cosine of 7t divided by 40. And that's evaluated between 0 and 40. Okay, almost there. We got this. One more line where we actually plug in these numbers and then we'll call it good. 1 over 40. Leave the 240. Okay, now we plug in these numbers. This is going to be plus 10. I'm going to bring the 10 on the outside, so 10 times sine of 40. 40 over 10. It could have just been 4, I guess. But I'm going to just show my work here. And that's going to be subtract sine of 0 over 40. By the way, sine of, you could have eliminated this if you were thinking that. Sine of 0 is just 0, so this whole thing turns into 0, but I'll just leave it here for the sake of showing work. Now this is going to be subtracting 120 over 7. I'm going to bring that to the outside, and that's going to be times cosine of 40 times 7, that's 280, divided by 40. I think that evaluates to something nice, but I'm going to leave it as a fraction, and that's going to be subtract cosine of 0 over 40, which does evaluate to just 1. This whole thing right there evaluates 1, but I'll leave it there. We still would have left it in there as 1. And end the final bracket. Wow, a lot of math. That is Form B for you. And if you did evaluate this on your calculator, which you're not going to, you would get this value. I did check it myself. It is going to be 5.916. Again, you don't need that, so you should kind of ignore this, but it's just to check your work at home, not on the test. Whew. Okay, and then we need to have the units here. So this is trying to find average velocity. So velocity is measured in miles per minute in this one. So it's going to be miles per minute. How to score that giant problem. That giant problem is out of 3 points to add to 9. And you get 1 point if you just got the limits. So you get 1 point if you got from 0 to 40. So plus 1 right there. Right off the bat, you could just get 1 point. Okay, and then you need this part. So the inside plus 1. And this, all of this extra work, if you got down to this step down here, so down here, that is plus 1. It was a lot of work to get to that last point, and maybe it's not worth it in terms of the time. I would agree with that, but that is how you get that third point. And that concludes self-check 9.4.